Hi everyone. In this video I will be demonstrating how to test for a violation of the homogeneity of regression slopes assumption in the context of a one-way analysis of covariance. And we're going to be working with SPSS version 28 during this demonstration. You also should see data on your screen. Basically this data is simulated for the purpose of this demonstration. And you can obtain a copy of this data by following a link that I provide underneath the video description. So with this data, we have individuals who received one of three psychological interventions. And so that's our grouping variable right here, treatment condition. Our dependent variable in our analysis is going to be well-being. So it's an interval scaled variable, again reflecting psychological well-being, theoretically as a function of receiving different psychological interventions. And then we have a covariate in our analysis, which is exercise. And basically you can imagine that this might be obtained prior to engaging in the treatment for individuals. So essentially measurement prior to treatment in terms of how often a person tends to engage in exercise. So when you're running the basic analysis of covariance, what we would be testing is whether there are differences in well-being as a function of treatment condition while controlling for differences or individual differences in the amount of exercise that a person engages in. And so the ANCOVA itself is essentially adjusting the means on well-being for any differences on exercise, so that we're essentially trying to eliminate a possible exercise confound. So before I actually demonstrate how to generate a test of the homogeneity of regression slopes assumption, let's just briefly specify the basic ANCOVA model and kind of walk through a few of the bits of the output. So we'll go to Analyze, go down to General Linear Model and Univariate. We'll move the treatment condition variable to the fixed factors box. We'll move well-being to the dependent box and exercise down to the covariates box. Just a few things that you might select under options: descriptives, effect size, power, homogeneity test. If you want to see the model reparameterized as a regression model, you can click on parameter estimates right there. We'll click on continue. Under EM means, this is the estimated marginal means, and the reason why this is really important is because the table of means that you would get by selecting descriptives is not going to reflect any type of adjustment for group differences with respect to the covariate in the model. So what we want are adjusted means on the dependent variable. So to obtain that, we're going to highlight these right here on the left and move them over to the right. If you want to do any kind of pairwise comparisons of those adjusted means, you can click on Compare Main Effects, and you've got a couple of confidence interval adjustments right here. I typically go with Bonferroni. So we'll click on Continue. Just briefly, we'll click on Plots and we'll move the treatment condition over. And when we click Add right here, we've got a couple of chart types available. I'll go ahead and click on Bar Chart and include error bars, and that's just going to give me a confidence interval, a 95% confidence interval around the adjusted means for each of the groups. So I'm not going to spend tons of time going through all of the details of this output, because the main focus of this video is on testing homogeneity of regression slopes, but I think it is important to kind of take a look at our output prior to performing that test. So we'll click on OK right here and look at our output. So you'll see, first off, with our descriptive statistics, we have our table of descriptives with means, standard deviations, and ends. And just keep in mind that the means that we have right here, these are unadjusted for the covariate. So in other words, basically these are not the means that we would really want to key in on when it comes to interpreting the results from our ANCOVA, because it doesn't reflect that adjustment. So we're going to eventually go down and take a quick look at those estimated marginal means that do contain that adjustment. So when we scroll down a little bit further, you've got Levene's test, the standard Levene's test, where we're testing for equality of error variances across the groups. And so the assumption is that the error variances or residuals across the groups are equivalent in terms of their variances. And so If this p-value here for the significance level, if it is say less than 0.05, then that would be an indicator that we have a lack of homogeneity of variances across the groups, which is actually a bad thing. If you have a p-value that's greater than 0.05, as we do right here, then that's signaling evidence that we have the assumption met. When we look down into the test of between subjects effects, you'll see that we have our independent variable right here, treatment condition. And you can see that we have this test right here is indicating statistical significance, which is essentially telling us that there are differences in the adjusted means across the groups. So that's what we would kind of expect if treatment condition would be having an effect on well-being. So then you'll see that we have the test for the covariate in the model. This is exercise, and you can see that this test is also statistically significant. So that's telling us that there's a relationship between exercise and well-being. So even after accounting for treatment condition, there's still a relationship that is maintained. When we scroll down a little bit further, you can see right here this table of parameter estimates. That's what I was saying before, that basically this is kind of a reparameterization of that ANCOVA in the form of a linear regression. So I'm not going to go too far into details, but that's what that table is for. When we scroll down a little bit further, you can see that we have the estimated grand mean, and it's adjusted for the covariates in the model. And then we have down in this table right here, we have the adjusted means for each group. So there's the adjusted mean for group 1, for group 2, and for group 3 right there. So there's not really much in the way of differences between group 1 and 3, obviously, but group 2 seems to be different from those other two, just kind of visualizing that. Scrolling down a little bit further, you can see then that we have pairwise comparisons. So you can see we have a comparison between group 1 and group 2. The difference between those two is 1.24, and it would be significant at the conventional 0.05 level. Between 1 and 3, you can see that there's no difference between those two, and then between 2 and 3, turns out that there's kind of the same amount of difference that we saw with between groups 1 and 2. It's just the direction is reversed, and you can see that that difference is significant. So that's just kind of a brief overview of the ANCOVA results up to this point. Now what we want to do is to test whether the regression slopes are equivalent across the three groups. So the reason why this assumption is important is that if there is essentially if the regression slopes are not equivalent, what that means is that the relationship between the covariate and the dependent variable is not constant across the groups, or to put it another way, that there's an interaction between the covariate and the independent variable. So to kind of visualize this, you'll see this oftentimes in textbooks where you'll see kind of graphs, if you will, or figures where you have a plot of the relationship between the covariate and the dependent variable in each of your groups. So for instance, let's say we have x and y right here, x and y right here for group 2, and then x and y right here for group 3. So the x being the covariate in our model. And so the assumption behind the analysis of covariance is that the regression line, the slope of the regression line, is going to be the same across those groups, or at least highly similar. So for instance, let's just say I draw out a regression line here, and then line here, and one right here. And you can see that all of these lines, minus whatever errors I'm doing in my drawing, all of those exhibit a fairly similar slope. Okay, so that's the assumption, though, is that the slopes should be equivalent. You want the same level of adjustment to the means on the dependent variable as occurring across the groups. And so the only way that can actually occur is by virtue of having the same regression slopes for the relationship between the covariate and the dependent variable. And what we don't want to have is a situation where the slopes vary. So to give you sort of a visualization of that, let's say that we maintain this positive relationship in group 1. Let's say there's no relationship in group 2, and let's say that there's even a negative relationship between the covariate and the dependent variable in group 3. So in this case, we would have a lack of homogeneity of regression slopes, and that's not an ideal situation when it comes to performing the standard analysis of covariance. So we can test this assumption out of homogeneity versus lack of homogeneity of regression slopes pretty easily in SPSS. And the way that we can do this is by going up to Analyze. We'll go back to General Linear Model and click on Univariate right here. And we'll go to the Model tab. So in this Model tab, what we can do is we can kind of add in an interaction term. So right now, with the full factorial as specified, it's just going to give us the default model. We want to click on Build Terms, and I'll move the treatment condition variable over. And by the way, we kind of want to keep this in main effects right now. We'll move our exercise variable, our covariate, over as well. And then we'll set this for interaction, and we'll highlight both of these and move it over. So now we're specifying a model that includes treatment condition, our covariate, and the interaction between our treatment condition, independent variable, and the covariate. So we'll click on Continue and then on OK. And so now when we scroll down, our output contains in our ANCOVA table down here, it contains the interaction term. So there it is, treatment condition by exercise. And so if this is statistically significant, that's going to signal that we have a violation of that assumption of homogeneity of regression slopes. And what that basically would suggest then is that it would be problematic to specify a model that does not contain that interaction effect. So you can see in this case right here that the test of the interaction effect is statistically significant, which is indicating then that we have a violation of that assumption. So it becomes problematic to then to stick with ANCOVA results that would not contain that interaction term. Now, the next logical question that folks will have at this point is, well, how do I describe this interaction and how do I make sense out of it given the remaining results that are present in the output? And to be perfectly honest, a really good way of just describing the interaction is to graph it. And there's not really a very efficient way of doing that using the standard menus through SPSS. But one thing that you can do is if you are familiar with Andrew Hayes' process macro, you can rerun the analysis by incorporating that interaction term in a linear regression, basically carrying out a moderated multiple regression version of this analysis right here, and then generating a plot of the interaction. So to show you what I'm talking about, what I'm going to do is go over here to Analyze. We'll go down to Regression, and by the way, you'll have to install this if you want to use this macro, and I'll be sure to include a link to it underneath the video description. So if we go to Regression and then go down to Process right here, what you'll want to do is to move the treatment condition variable over to the X variable box. We'll move the well-being variable over to the Y variable box, and then the exercise variable. Now you'll notice that it says covariate down here, but we don't want to move it to the covariate box. We actually want to move it down to where it says moderator variable. And we're going to set the model number, leave that set at 1. So what's going to happen is that it's going to generate a multiple regression model that incorporates the effect of treatment condition, the effect of exercise condition, and then it's also going to generate the interaction between the two. So I'm not going to go into all of the details about how this is accomplished, but just that's essentially what's going to happen. If you click on multi-categorical right here, you can click on where it says variable X. Variable X in this context is going to be the treatment condition variable. So if I click on the variable X right there, the coding system is actually set for dummy coding or indicator coding. So we're just going to leave that set there. And then under options, I tend to prefer to center my continuous variables. So I'm going to go down here where it says only continuous variables that define products, basically mean centering for the construction of products. We'll also want to generate code for visualizing the interaction, so I'll select that. And then down here where it says conditioning values, we're just going to leave this set at 16th, 50th, and 84th percentiles. So essentially what's going to happen is that we're going to be plotting intersections of basically the mean associated with the intersection of the treatment factor and of these conditioning values with respect to the covariate in our model. So again, these are the selections that I've made right here for this particular demonstration. So next up, we'll click on continue and then on OK. And so it takes a couple of seconds to generate some output. And just briefly, before I show you how to plot that interaction, what you'll see up here is basically kind of a dummy coding of the treatment variable. So this is the original variable right here, and in order to model this through regression, what's happened is that this variable treatment condition has been recoded into two variables that contain all of the grouping variable information. So you'll see that group 1 is coded 0 on both x1 and x2 dummy variables. That actually makes group 1 the reference category, and then for group 2 it's coded 1 on the first dummy variable and 0 on the second, and then group 3 is coded 0 and 1 on x1 and x2 respectively. So that actually has implications for how you interpret the difference, interpret the regression slopes associated with x1 and x2. So the regression slope for x1 would be a difference between group 2 and group 1. The regression slope for x2 is the difference between group 3 and group 1. So that's kind of the basic idea there. So you'll see next we have the parameterization of our model that contains the interaction using linear regression. So you'll notice down here we've got the two dummy variables that are incorporated as predictors of well-being. You'll see that we've got our covariate exercise right here, and then we have interaction terms that are formed as a product of x1 and exercise and x2 and exercise. So that's the INT1 and INT2 that you see down there, and here's a little key that shows you what that is. So the next thing to kind of note is right here in this section, this is actually a test of that interaction effect that we saw previously in the ANCOVA table. So the x by w that you see right here, the f value and the p value that's given is literally the same as what we had before when we were looking at our results when we ran our analysis using the general linear model in SPSS. So there are various, you can see right here we have simple effects tests and so forth. I'm actually just going to scroll down and keep this fairly simple just by showing you a plot of the interaction. So down here at the bottom, I'm going to double click in this box of output, and so you can see it kind of highlights around. There's like little dotted lines, maybe a little bit hard to see, but you can see the dotted lines around all of this. This will allow me to copy information from my output file. So if I highlight all of this and copy it, what I can do is go to File, New, and then go over to Syntax. And in a new syntax file, I'll just paste all that in. So now when I highlight all of this and click the green button right here, you'll see that I get a plot of the interaction, if you will. And just to make it a little bit easier to see, we'll double click inside here as well, and we'll click on Add Fit Line at Subgroups. So when we do that, you can see that we get regression lines that are plotted. And I'm going to get rid of the labels to the line just by clicking off Attach Label to Line and then click Apply, and there you go. So now as you're looking at this, you can see that treatment condition 1 is reflected in the blue line, or the very light blue line, and you can see that for individuals in treatment condition 1, there's not really much of a relationship between exercise and well-being. It's actually, if there is a relationship, it's only very slightly negative. So that's that group right there. Then we have treatment group 2, which is the green line that you see. So you can see that there's a positive relationship between exercise and well-being for those individuals in treatment, in the second treatment group. And then you can also see a positive relationship as reflected in this red line right here. That is for treatment group 3. So you can see that if there was no interaction effect that was taking place, the expectation would be that these lines would be parallel to each other. But as you can see, because they're crossing over or intersecting, that's indicating that we have that interaction that's taking place. Now we can also look at this in a slightly different way by looking at differences in means on well-being at different levels of exercise. So remember that we had requested the 16th, 50th, and 84th percentiles associated with our exercise variable. So you can imagine then that at this point right here, this is roughly the 16th percentile on our exercise variable. Where this plot is right here, this is roughly at the 50th percentile of the original variable, and then this is roughly the 84th percentile of that variable. So you can see that with respect to well-being, that if we just look at the 16th percentile of the exercise variable, you can see that we have group 1 having the highest mean on well-being, followed by group 3, followed by group 2. So there's there are differences in those means. Then for individuals falling at about the 50th percentile on exercise, you can see that individuals in the group 3 actually have the highest mean. Individuals in group 2 have the next highest mean, followed by individuals in group 3. And then among those individuals falling at the 84th percentile, what we have is the highest mean for group 3 individuals. We have the next highest mean for group 2, and then the next highest mean obviously for our in this case we have group 3 group 3 has the highest mean at the 84th percentile, followed by group 1, followed by group 2. So it's very easy to kind of get confused if you're not careful as you're going through this. But you can see that there's not much of a difference between the means on well-being for groups 1 and 2 at the 84th percentile, whereas you see much more substantial difference at the 50th percentile, and obviously again at the 16th percentile of our exercise variable. So just so you know, you can also go through the other pieces of the output and report kind of simple effects tests if you want to do that. I'm not going to get into that right here, but I'm just letting you know that that information is available to you. So that concludes this video presentation, and I appreciate you watching.